Hello everyone, I hope you all are doing great. For today's video, our topic would be formation of X-rays. Alright, so this is gonna be a long detailed video and stay with me till the end. Alright, so first of all, the idea of X-rays was given by Roe engine. Alright, Roe engine is the name of the scientist. He gave this idea. Alright, and the first name of X-rays was Roe engine rays. Alright, so let's just discuss the phenomena and the working principles of X-rays. So if we could start from the working, how these X-rays are formed. For example, let's just start. Alright, when the high voltage or high speed of cathode strike to heavy metal anode, and the rays emit. Those rays are said to be X-rays. Alright, let's just understand this by the practical. For example, this experiment was done in the discharge tube, and the voltage, the battery of source, it was connected with 50,000. The volt of the battery would be 50,000 high voltage. Alright, this is the source of a battery, and here we have the cathode ray, and here we have a heavy metal anode. Alright, so when the battery will start giving the power to cathode, so these cathode rays will be going to the heavy metal. We're gonna use the heavy metal of anode. When they will going there, they will striking to the anode. In the result of that, the X-rays are being produced. Alright, how they're gonna produce, we're gonna understand it by the atomic model. Alright, for example, we have the K L M. Alright, we have the, I have written the name of the three shells as well. So here, for example, by discharge tube, we have strike the heavy, the high speed. We have used the high speed with the kinetic energy would be very high velocity, high speed source of electron would be striking to this electron, and it will deflect, it will break. Yahan se electrons are coming, they will go here, and this electron would be come out. Alright, when it will come out, so the radiation will emit. Alright, radiation will emit, and uske baad this electron will come out. Alright, so there would be a vacancy of one electron. When there would be a vacancy of one electron, so K electron would fill this vacancy. Alright, K electron would come here and would fill this vacancy. Alright, Alright, so now we're gonna talk about few characteristics. Alright, so for example, L, M, N. Alright, so when the vacancy of K would be there, so that will be called as K alpha. Alright, when M will be filling the vacancy of K, so that will be called as K beta. Alright, and when N will be filling the vacancy of K, that would be called as K gamma. Alright, at a time L, M and N, only from these three shells one can fill the vacancy of this electron. High speed, high velocity, kinetic energy. When they'll strike to this, these electron kinetic energy would be low. Alright, high kinetic energy. Alright, and when the electron from L to K would be shifting, so this electron would emit energy. Alright, because here the work of shifting is being done. Alright, now this was the X-rays series, means K series. Alright, now we're gonna talk about the another example that will be of L series. Alright, for example, this is K shell, this is L shell, this is M shell, and that is N shell. So for example, now consider the low energy and low velocity cathode and the low kinetic energy cathode we are giving the source, but the electron of L shell is being replaced, because the striking of this rays would be on the L shell due to low energy. We'll give this depend on us. Just explaining you. Low velocity, you can say it would be low penetration. Alright, so low penetration power field will be giving, so of course this ray would not be reaching to near to the nucleus between the K and the nucleus, so it would reach to L or M or N. So on that time the vacancy of L would be fulfilled with M shell and N shell. That must be known as K alpha, and when N will be filling the vacancy, so that will be known as beta. Alright, यहाँ पे it will strike to this electron will come out, and these electron will come out, so automatically the electron will come out and this place would be get empty. Then these electrons, M shell electrons, would be shifted here. Alright, now we're gonna talk about the spectrum. Alright, we're gonna talk about the spectrum of X-rays. Spectrum. Alright, so from the anode heavy metal, the cathode is being the particles of the radiation of the X-rays are being emit. So here we have placed a crystal, or you can say a potassium ferrocyanide, to detect the spectrum. When it will strike to this, and it will split into photographic form, and it will make a spectrum of X-rays like this. Right, consider this is the anode from the discharge tube. I'm not making the whole discharge tube. Okay, let's just make it. This is cathode. Alright, so we have placed a, place a potassium ferrocyanide. That's a crystal. When we place directly, you can say when we place a crystal, so it will form the spectrum in a straight line. Alright, and you need to remember each element has its own characteristic of X-rays, alright, and X-rays are produced in all direction, alright. You can see X-rays are produced in all the direction. You need to remember these few phenomena. Now here I'm gonna start the Moseley's law, alright, which was related to the production of X-rays. Moseley's law. What Moseley's law states? Moseley's law states that K series, means K electrons, have the shorter wavelength, alright. They have the shorter wavelength, right? And the L series have, the long wavelength. It was the law of Moseley. So what actually Moseley stated, he gave the series, statement of K series. What he stated, that the wavelength is inversely proportional to the square of atomic number of any element you are taking, alright, of any element you are taking. And he also stated that wavelength is inversely proportional of the atomic number, but frequency is directly proportional to the atomic number, alright. Now we know that the frequency the symbol is mu. Mu is directly proportional to the z square, alright. Now we're gonna take the square root on both sides. So when we're gonna take the square root on both sides, the mu will be in the square and directly proportional. Z square would be remain. When we need to remove this proportionality sign, so we know that we have a constant, that is A Z minus B. I'm gonna tell what is that. So let's just name. Mu is the frequency, A is the proportionality constant, alright, and Z is the atomic number, and B, that's B, is a screen constant, and that is between the electrons. Screen constant of metals, alright. Now we're gonna see few the graphs. Okay, so always remember, it's a general conversation, general discussion, that when we have the directly proportional graph, for example, frequency is directly proportional to the atomic masses, so the graph between that would be straight line. Let me just draw over here. For example, this is frequency, and so the graph between them is straight, right? Alright, but due to what? Due to the proportionality. But always remember, in the constant quantities there is no graph, alright. So we can say that when the frequency of the X-rays is increased, so the atomic number is also increased, alright. This shows the directly relationship, alright. I hope that is clear, the production, how the X-rays are being formed. The X-rays are being formed when the high speed, high velocity, high kinetic energy cathode rays strike to the heavy metal of the anode, and they split the radiation from the discharge tube, and this atomic structure to be occur, that will be then the formation of the X-ray. I've told you the characteristics, the K series, the L series, alright. You need to remember this. Thank you so much for watching.